Welcome to this webinar on the business implications of airworthiness, overcoming the challenges of certifying next-generation avionics software with SYSGO and LDRA.
For LDRA, I'm Steve DiCamillo, Technical Marketing and Business Development Manager. I'm based in the U.S. near Boston, Massachusetts, and I've been at LDRA for a little over 5 years. Much of my career has been focused on model-based systems and software engineering, in particular in support of the development and verification of safety and security critical embedded systems. I'm a member of IEEE, SAE, and NCOSE.
From the SYSGO side, my name's Joe Richmond Knight, and I've been with SYSGO for about 3 years as a field applications engineer, working as part of the global technical sales team. I'm based permanently out of the UK, and I'm an active member of the IET, and I've spent my career working with embedded systems and technologies. The agenda for today is as follows. Stephen and I will do a short introduction of our organisations before I go into a deep dive of the current landscape and implications. Stephen will then present the LDRA and SYSGO solution, explaining how we address these implications jointly. Finally, Stephen will wrap up with the conclusion before we start the joint Q&A session. SYSGO is one of Europe's top vendors for real-time operating systems for embedded systems. We focus on supporting 3 key products: PikeOS, a real-time operating system and hypervisor built for safety and security critical applications; Ilinos, a Linux distribution specifically designed for embedded systems that need long-term support; and PikeOS for MPU. Think of this as the little brother to PikeOS, offering a certifiable RTOS for MPU-based systems. With our specialist engineering team, we don't provide just software, we deliver fully integrated, certifiable, and supportable solutions for our customers. Since 2012, we've been part of the Thales Group, which means we get to uphold strong ethical policies whilst maintaining our own brand and identity. On top of that, SYSGO is all about quality and security. We've earned ISO 9001, ISO 27001, and Common Criteria certifications for cybersecurity. Plus, we're ITAR free, so there's no geographical restrictions on where and how PikeOS can be used.
LDRA is an established leader in the verification, validation, and assurance of critical embedded software. We have been consistently setting industry benchmarks through our pioneering solutions for 50 years. Central to our business success is understanding our customers' needs and aspirations in achieving critical embedded software aims, whether they are to achieve certification targets or to simply improve software quality. In tandem with our customer-focused certification services and consultancy offerings, LDRA products achieve early error detection and elimination, tracing requirements through static and dynamic analysis to unit testing and verification for a wide variety of hardware and software platforms. Because our products are designed to be used on critical applications, we have always taken the quality of our products very seriously. The company's quality management system has been ISO 9001 certified since 1993, and LDRA products were first TÜV approved in 2013. LDRA's products are certified for a variety of software safety standards across many industries. We also actively participate in several safety and security standards organizations, including MISRA C and C++, DO178C, and ISO 26262. As a recognized leader in the verification, validation, and assurance of critical avionics software, LDRA products have been used on over 280 DO178 certifications for over 100 companies, including over 125 DAL-A certifications.
So both SYSGO and LDRA work across all major industries where safety and security are top priorities. So no matter the sector, every industry needs to focus on reliability, robustness, fault tolerance, and rigorous verification and validation. So for today's webinar, we'll be diving into the aerospace sector and exploring some of the exciting new developments shaping the next generation of air vehicles. That said, the technologies and methodologies we'll discuss aren't just for aerospace, they're just as relevant in other industries too. So let's take a look at the emerging markets. The aerospace industry is really starting to pick up momentum with a wave of exciting next generation developments. One of the biggest game changers? eVTOL, so electric vertical takeoff and landing aircraft. A number of companies are working on these futuristic air vehicles, and experts predict that the eVTOL market could be worth anywhere between 20 and 30 billion US dollars by 2030. So what are they actually being used for? Well, there are quite a few applications, things like air taxis for passenger transport, freight delivery, public safety, and even things like infrastructure maintenance. This diversity is great because it drives innovation across different tech platforms, but it also comes with its own challenges. One big hurdle is the reduction of size, weight, and power, often known as SWaP as an acronym. Fortunately, modern multi-core processors are helping with that, but optimizing these systems through techniques like mixed criticality and power management is something that needs careful attention. Interestingly here, we're also seeing some crossover from the automotive world. Just like how cars integrate infotainment with digital instrument clusters, Avionics seems to be heading in the same direction. Both passengers and operators alike now expect a sort of seamless performance and an intuitive user experience. But with this advanced technology, of course, comes a new challenge: cybersecurity. These complex systems have a much larger attack surface compared to, say, a traditional flight system. So it's not just about making them safe, it's about making them secure too. Now let's talk about some of the emerging markets and evolving standards that are shaping the future of aerospace and beyond. Like I said on the previous slide, we're seeing major advancements in areas like urban air mobility, unmanned aerial systems, and eVTOL aircraft. These technologies promise to revolutionize air travel, but they also come with a unique set of challenges. For starters, these new technologies and use cases, as they emerge, we're facing new safety, security, and regulatory hurdles. Traditional development approaches are evolving to keep up, and we're seeing a shift in programming languages as well. The programming language C has been the industry standard for decades, but we're now seeing increasing interest and use of languages like C++ and Rust, especially for safety and security critical applications. These languages can bring modern features essential for next-gen aircraft systems. However, with great power comes great responsibility, and in this case, great care needs to be taken to use these languages in a safety-focused way. On top of that, agile practices and iterative development are being widely adopted to accelerate time to market. The goal is to field new capabilities faster whilst maintaining high levels of reliability and certification compliance. And of course, with these new technologies comes new cybersecurity threats. As attack surfaces expand, we need to rethink our approach to security. That's where concepts like DevSecOps come in, integrating security throughout the development lifecycle rather than treating it as an afterthought. Cybersecurity certifications are also becoming increasingly important, ensuring that these systems meet the highest levels of security standards before they ever take flight. In short, we're navigating an exciting but complex landscape, and adapting to these challenges will be key to delivering safe, secure, and future-proof solutions. Let's dive into some of the business implications that the next generation of aircraft are presenting. First, emerging markets are a big opportunity for the aviation industry. By understanding the type of aircraft needed, whether it's more flexible or sustainable solutions, companies can adapt their aircraft to meet those demands, unlocking new revenue streams. But it's not all smooth sailing. Companies will also need to navigate a variety of regulatory environments, so staying flexible and agile will be key to taking advantage of these opportunities. Now, when it comes to code certifiability, it's of course essential, but can also be costly if not properly handled. While agile methods are great for speeding up time to market, they don't traditionally mesh well with the strict safety and certification requirements of the aviation industry. Speed is important, but companies need to strike a balance between pushing innovation and making sure safety validation is thorough, so additional effort is required to implement agile development processes. If this balance isn't managed properly, it could lead to higher costs and increased risk. Finally, as aircraft systems become more interconnected, cybersecurity becomes an even higher priority. These systems present new vulnerabilities, so it's crucial to manage the attack surfaces carefully. Any breaches could seriously damage a company's reputation, erode customer trust, and even lead to a major safety incident. So building strong cybersecurity frameworks can be expensive if not done efficiently, but not doing so could leave a company exposed to legal, financial, and regulatory trouble. Over the next few slides, we'll talk about the features of how LDRA's tool suite and PikeOS can be used in combination to address these business concerns. So as I mentioned on our introduction slide, PikeOS is SYSGO's flagship product, and it's pretty powerful. It combines a real-time operating system with a Type 1 hypervisor, all wrapped into one highly portable OS supporting all major architectures used in safety and security critical systems. It supports multiple application environments called personalities, which can be thought of as like guest operating systems or application environments. First, there's PikeOS Native, which provides a highly certifiable C programming environment and an API set that can be used to interact with the rest of the system. We also have a POSIX personality, which implements part of the POSIX PSE52 profile, as well as some real-time extensions. Next, there's our Apex personality, which provides an IMA environment compliant to parts of the ARINC 653 standard. And finally, because PikeOS is a hypervisor, it's able to host fully fledged OS guests like Ubuntu, eLinos, our Linux distro, Android, or even Windows. Modern architectures supporting hardware virtualization capabilities can also be leveraged for more performance, also requiring less modification to the guest OS itself. Thanks to its separation kernel architecture, PikeOS allows you to run different applications with varying levels of criticality on the same system. So this is really important for today's topic, as it allows high criticality applications to run alongside low or even non-critical apps. So you could imagine a Linux guest running alongside a DAL-A application, for example. On top of that, and I'll cover this more on the next slide, PikeOS is fully certifiable to the highest safety and security standards, making it a reliable choice for safety critical applications. With PikeOS, we deliver an Eclipse-based IDE called Codeo, which is set up for a streamlined PikeOS development process and includes a number of useful debugging tools. So as I said, and a big takeaway for today is that PikeOS is certifiable up to DO178C DAL-A for civil avionics, which is the highest level of software safety available or achievable in aviation. But it doesn't stop there. Since PikeOS is built to meet various safety standards, it can also be certified to the highest level of other major safety standards like IEC 61508 for industrial applications. To meet the needs of modern multi-core platforms, PikeOS comes with a set of technologies designed to align with AMC 20193 guidance. When it comes to security, PikeOS is fully equipped. It's achieved Airbus SAR SAL 3-4 and recently hit common criteria EAL 5+ with the latest version of the PikeOS separation kernel 5.13. SYSGO has a strong background in safety critical software, so we've got the expertise to support certification projects and will continue to provide products and services that meet the highest standards. So what's PikeOS's approach to certification. So we provide a modular approach. The kernel itself, in this diagram you can see here, is built of three main components. So there's a small kernel layer which is generic regardless of platform. We then have the architecture support package, which is part of the kernel responsible for supporting the processor architecture. So we have an ASP for ARMv8, an ASP for x86, etc. And finally, as part of this kernel layer, we have the platform support package, the PSP, which can be thought of as like a minimal board support package. So it's like a board support package without any of the peripheral drivers. On top of the kernel is the PikeOS system software, the PSSW, which runs in user space and is responsible for initializing the various partitions as well as starting the system. So the microkernel, PSSW, and architecture support package are available as certifiable components out of the box. So they're supported through the delivery of PikeOS alongside our certification kits, which includes test evidences and safety manuals, for example. The platform support package is usually developed and certified in the context of the project because it tends to rely on specially customized or unique hardware based on the overall system. As PikeOS is modular, we also offer a number of certifiable component add-ons. So we have a certifiable math library that allows the safe use of the floating point unit, the certifiable IP stack, which provides a UDP IP library, the certifiable file system, which provides a fail-safe embedded file system, as well as a number of other modular products and certifiable APIs. These are also supported with their own certification kits where applicable. As I mentioned earlier, PikeOS can be used to follow AMC 20193 guidance, and there are a few key ways it helps to manage risk. Here are some examples. Cache access contention can be handled by dividing the cache, which is also known as cache coloring. Modern SoCs even have hardware that helps manage this division. Memory access contention is addressed through things like bandwidth monitoring and rate limiting to make sure things stay running smoothly. The risk of interrupt overload can be minimized by using time partitioning on interrupt-driven drivers, for example. Scheduler contention is managed through the scheduling mechanisms as part of the PikeOS system. And when it comes to IPC contention, there's not a concern as long as you use queuing and sampling ports, which is a feature of Avionics 653, but ingrained into PikeOS because they don't impact the partitions that aren't involved in the communication. So just some examples here, but PikeOS is fully capable to support multi-core CPUs, and actually it's achieved DALE certification already in multiple projects. So, SYSGO's history and security. PikeOS was originally designed to meet some of the most stringent safety standards, particularly for systems where human life is at stake. Over the past 20 years, SYSGO's built a strong track record in safety certifications, developing expertise in real-time operating systems and safety certification processes. This background gave us a solid foundation to address the growing importance of security. Interestingly, although security wasn't separately addressed when PikeOS was first conceptualized, the fact that PikeOS was built to meet such high safety standards turned out to be a huge advantage when it came to security. A product designed to withstand safety risks is naturally well equipped to handle security concerns as well, and the artifacts created to demonstrate safety assurance, like documentation and processes, are just as relevant when it comes to meeting security standards. In fact, you can almost argue that security is a subset of safety. A system designed to resist intentional attacks is inherently designed to handle accidental events, since those can often be simulated by an attacker. Over the last 10 years, SYSGO has built expertise in security certification, focusing on the processes needed to achieve and maintain ISO 27001 and Common Criteria certifications. This has allowed us to ensure that PikeOS is not only safe but also secure, therefore meeting the highest standards across both areas. This expertise in part is derived from our safety experience, but also from things like cybersecurity and maintenance we've been putting into Linux, our Linux distribution, for some time to make sure that CVEs are monitored and addressed. PikeOS's separation kernel has been assessed to achieve common criteria EAL5+, which means it's achieved all of the criteria of EAL5, as well as some of the components of EAL6 and EAL7. And this is actually typically regarded as the highest level an OS can achieve out of context of the rest of the system, so it's quite a big achievement. The common criteria target of evaluation for PikeOS focuses on many of the concepts also used for the build of safety critical systems, like partition separation, control of information flow, resource partitioning, and confidentiality. Because the common criteria standard itself is industry agnostic, it can be mapped to many other industry-specific standards quite nicely through the use of compliance matrices. In fact, we carried out this exercise showing that it would be possible to achieve many other standards with minimal effort using the common criteria evaluation we already have. So tangentially, how does PikeOS work for DevOps and, more importantly, DevSecOps? So DevSecOps is all about weaving security into the DevOps pipeline, making sure it's a priority at every stage of software development. By automating security testing, continuous monitoring, and compliance checks, it helps teams catch vulnerabilities earlier, reducing risk and boosting software reliability. So what does that actually mean for PikeOS? If we start on the left from a development perspective, our IDE, Codeo, and the PikeOS CDK offer a range of tools designed to simplify the build and testing process for safety-critical embedded systems. For example, we have our Trace tool for remote debugging and the Muxer agent, which acts as a multiplexer for application and system consoles. And when it comes to ensuring high-grade code quality, our ecosystem integrates seamlessly with tools like LDRA's tool suite. But I'll let Steve dive deeper into that. Another key advantage is that Codeo and the CDK can be fully orchestrated from the command line. So that means all of the tools available in the IDE can also be used in an automated test pipeline. So if you've ever spent ages trying to push an updated application to an embedded target for a simple code change, you'll know how much of a time saver this could be. On the security side, our certification kits and security bulletins help teams stay ahead of evolving cybersecurity risks. So by creating a proper feedback loop, we ensure security remains an ongoing, adaptive process, not just a one-time checklist. So what does PikeOS provide for certifiable language support? PikeOS itself has supported the C programming language since the product's inception, and is also able to support other safety-focused languages like Ada through the use of third-party tools. The C language and GCC compiler provide the primary environment for our safety certifiable solutions. Much like C, PikeOS itself has supported C++ for quite some time, and we have a number of environments where C++ may be used in a certifiable way. So firstly, we have available a certifiable C++ STL for our POSIX environment, which is currently targeted for low to medium certification levels, but higher levels are possible in the future. And this C++ STL, or standard template library I should say, provides a set of common classes for C++ which can streamline the development of safety critical applications, in particular ones that may have been ported from traditional and maybe non-safe C++ systems. The second is a C++ runtime executable available for both our PikeOS native and Apex environments. This can typically support higher certification levels like DAL-B for PikeOS native. This runtime provides the core infrastructure required to support the usage of C++, whilst giving the developer the freedom to implement their own custom libraries tailored to the specific use case. More recently, by incorporating Rust into PikeOS, we've taken the first step in enabling the use of a language with a strong focus on safety, performance, security, and reliability. Whilst today the solution is not certifiable, we hope that this initial integration will provide the foundations for future exploration and certifiability for Rust on top of PikeOS. Okay, now I'll hand over to Steve to talk about LDRA's product solution.
The LDRA tool suite is a flexible platform for producing safety, security, and mission-critical software in an accelerated, cost-effective, and requirements-driven process. The tool suite's open and extensible architecture integrates software lifecycle traceability, static and dynamic analysis, unit test and system-level testing on virtually any host or target platform. All of these capabilities work seamlessly with PikeOS and the Codio IDE. The tool suite enables safety and security critical software development teams to achieve certification or approval in accordance with rigorous standards in several industries, including aerospace and defense, automotive, industrial and energy, medical devices, and rail transportation. Achieving compliance with these standards raises several challenges: tracking progress against objectives, establishing and maintaining bidirectional traceability across requirements, code, test cases, and test results, complying with coding standards for both safety and security, performing data and control coupling analysis, performing structural coverage analysis including MCDC coverage, data and control coupling coverage, and function and call coverage. Timing analysis, including timing analysis of applications running on multi-core processors to measure worst-case execution time. On-target testing, both virtually with a simulator and on a physical target. Performing object code verification when required for the most critical of applications. Complying with tool qualification objectives and requirements. And finally, managing compliance artifacts, evidence, and reports. We'll explore some of these challenges in the next few slides. Speaking of standards, there are several newer and evolving standards focusing on unmanned aircraft systems. Our TCA SC 228 focuses specifically on developing minimum operational performance standards for unmanned aircraft systems. ASTM F3201-16 specifies standard practice for ensuring dependability of software used in unmanned aircraft systems. And dependability includes both the safety and security aspects of the software. ISO 21384 is a series of international standards specifically focused on unmanned aircraft systems. This series provides guidelines and recommendations for various aspects of UAS operations, including safety management, operational procedures, and risk assessment. Both the FAA and EASA require compliance with safety and security related standards and guidelines. The FAA and EASA regulate UAS operations in the United States and Europe respectively, and have established rules and standards to ensure the safety and security of UAS operations. These regulations cover various aspects, including pilot certification, airspace restrictions, operational limitations, and airworthiness certification. And depending on the type and intended use of the UAS, DO-178C or ED-12C may apply. Looking more specifically at security from a U.S. perspective, both NIST and DFARS include security guidelines and requirements. NIST provides guidelines and best practices for cybersecurity in UAS systems. These guidelines cover topics such as secure communication protocols, data encryption, authentication mechanisms, and overall software quality. DFARS includes cybersecurity requirements for UAS and other defense systems procured by the U.S. Department of Defense. These requirements aim to protect sensitive information and ensure the integrity and security of UAS systems. It's worthwhile noting that by and large, the newer and evolving standards focusing on unmanned aircraft systems augment rather than replace existing aircraft and avionics standards. One of the challenges we talked about is establishing and maintaining bidirectional traceability across requirements, code, test cases, and test results. Being able to show that all software requirements are implemented in software and tested by test cases is critical for meeting requirements-based testing objectives, which are a cornerstone of many functional safety standards. In addition, the traceability reports and visualizations can easily highlight software that does not trace to a requirement, software that is not tested by a test case, or test cases that do not trace to requirements. Software that does not trace to any requirements could potentially go untested and may result in a safety risk or security vulnerability. Developing complex safety-critical systems is an iterative and incremental process. Due to evolving functional and technical requirements and to the release of new or changed safety standards or regulations, a change during the development cycle is inevitable. For safety-critical product development, a formal and efficient change management process should be implemented and enforced to make sure that unapproved changes at any stage or level of the development are not allowed. Here is an example of an impact analysis performed on a system requirement. If we change a requirement or source code or a test, it's important to understand what other design and test artifacts, both upstream and downstream, need to be reviewed and potentially modified. In the diagram, we can see the impacted artifacts are marked as suspect or are highlighted. Understanding this impact will help the development and test teams to assess the complexity and risk of making change. When we need to resolve a problem, we typically need to choose from several alternative solutions. The insight provided by impact analysis provides critical information into the decision-making process to choose the optimal solution. After we've selected the optimal solution, then the same traceability and impact analysis allows the development and test teams to systematically inspect, analyze, and modify the impacted artifacts, making the process of change management more predictable and eliminating the possibility of a change slipping through the cracks. Both impact analysis and change management are possible because of the project-wide traceability that has been established. Another challenge is coding standards compliance. Static analysis plays a crucial role in ensuring coding standards compliance, as well as assessing overall code quality, maintainability, and testability. Static analysis allows developers to identify potential safety issues and security vulnerabilities early in the development process, even before code is executed. This enables proactive mitigation of problems before they manifest in operational environments. Static analysis promotes consistency in coding practices and helps prevent common security pitfalls, such as buffer overflows, injection attacks, or insecure cryptographic implementations. To address the demand for more capable, safer, and more secure programming languages, the de facto languages used to develop safety-critical embedded software have evolved. Both the C and C++ languages have been periodically updated, and the tools like the LDRA tool suite have evolved alongside them to provide up-to-date and comprehensive analysis of the new language features. Static analysis is seamlessly integrated with SYSGO's PikeOS and the Codio IDE. Static analysis can be integrated into CI/CD pipelines to automate code analysis and verification as part of the software build and deployment process, including DevSecOps that we'll discuss a little later. Static analysis tools can analyze large code bases efficiently, making them suitable for projects of varying sizes and complexities. NIST, along with other organizations that develop guidelines for secure coding, recommend the use of static analysis as part of its guidelines for software security assurance. NIST best practices and methodologies for ensuring the security of software systems include static analysis as an essential component of a comprehensive security testing strategy. For example, NIST Special Publication 800-64 Revision 2, Security Considerations in the System Development Lifecycle, emphasizes the importance of static analysis in identifying and mitigating security vulnerabilities during the software development process. NIST references CWE in its publications and guidelines related to software security. CWE provides a comprehensive catalog of known software security weaknesses, which can be used to guide static analysis efforts and prioritize the identification and remediation of security vulnerabilities in software. Static analysis can also be a valuable component of an organization's efforts to comply with requirements of IEC 27001, particularly in the context of identifying and mitigating security vulnerabilities in software systems. One of the core requirements of IEC 27001 is conducting a risk assessment to identify and prioritize information security risks to the organization. Static analysis tools can be used as part of the risk assessment process to identify security vulnerabilities and weaknesses in software systems, which can then be evaluated and treated according to the organization's risk management procedures. So far, I've discussed methods for overcoming challenges with compliance that have not required the software application to be running on a virtual or physical target hardware. The next set of challenges I'll discuss will be addressed by running the software application on a virtual or physical target. Automated unit and integration testing tools automatically create test harnesses and test scripts and can automatically run the test scripts to verify the software provides the expected results. Together with a debugger, these tools can help the developer or tester find the root cause of errors. As changes are made to the code or tests, then automated regression testing can be performed to quickly determine if the errors have been corrected or not. The LDRA tool suite extends these capabilities with automated test case generation. These capabilities can be used to generate requirements-based tests using equivalence class testing and boundary value testing techniques. In addition, automated test case generation can be used to create test cases that augment requirements-based tests and focus on robustness and fuzz testing. When required, structural coverage usually must be performed on the same hardware that will be used in the operational system. For example, the certified hardware platform that will be used in an avionics system. It's important to use a testing and verification solution like the LDRA tool suite that can measure many different levels and types of coverage, works with a wide variety of embedded environments, and provides tool qualification packages as well as being certified to numerous industry standards. Depending on the standard and the level of criticality, statement coverage, branch decision coverage, or multiple condition decision coverage may be required. In addition, some standards require data and control coupling coverage, which help assure software is safe and secure, especially when running on a multi-core processor. As with static analysis, dynamic analysis, including coverage analysis, is seamlessly integrated with Cisco's PikeOS and the Codio IDE. And dynamic analysis can also be integrated into CI/CD pipelines to automate software testing and verification as part of the software build and deployment process. In addition to structural coverage of source code, some standards require structural coverage of object code. For example, for software that must meet Design Assurance Level A objectives for DO178C. As performance needs increase, developers are typically increasing optimization, resulting in further differences between source and object code. Object code verification is intended to identify potential safety and security issues resulting from these differences. The key here is intended functionality. Specifically, the functionality verified at the source code level must be 100% consistent with that implemented at the object code level. The verification team can establish this by exhaustive documentation of the tool chain and the process followed. Alternatively, they can demonstrate this consistency by utilizing the LDRA tool suite. Manually reviewing traceability from source to object code is impractical and error-prone. The LDRA tool suite works with several microprocessor architectures, including PowerPC, ARM, and x86, and can be extended to allow for adjustments around varying instruction sets. Using qualified automated test tools is always preferable over manual inspection and extensive toolchain documentation. Data flow analysis and data coupling coverage in multi-core avionics systems involve understanding how data propagates between different processing units or cores. This analysis is essential for identifying data dependencies, parallelism, synchronization mechanisms, and pipelining strategies. Challenges such as managing parallel execution, ensuring data consistency, and minimizing data transfer latencies necessitates a thorough examination of data flow patterns. By leveraging industry-leading tools for static analysis, developers can gain valuable insights into data movement and optimize task execution times accordingly. The emphasis on data flow also ensures the flow of data from the starting point of the data generation all the way through to where the data is consumed as specified by the requirements. Therefore, obtaining data flow analysis does not only help with worst-case execution time measurements, but it is also a crucial task in the safety and security software lifecycles. The concepts of control flow analysis and control coupling coverage revolve around the sequence of procedure calls and executions in a program. These procedures are called and executed based on decisions and calls from preceding procedures. Therefore, ensuring that these procedures are called and executed as expected according to requirements is critical in avionics software. Control flow analysis focuses on these decision points to provide a more intuitive representation of behavior, known as control flow graphs. This, in turn, helps developers ensure that code aligns with the requirements. Additionally, for multi-core software, control flow analysis is related to the sequencing and interconnection of instructions across multiple cores. Techniques such as data prefetching and task scheduling play pivotal roles in controlling the order of execution and minimizing contention among cores. Addressing challenges such as branching, looping, and interrupt conflicts requires a holistic approach to control flow analysis. By integrating control flow analysis with data flow analysis, developers can effectively mitigate timing uncertainties and ensure deterministic task execution. Another area of software testing is determination of worst-case execution time. With the complexity and capabilities of today's microprocessors, determining worst-case execution time is challenging. When using a multi-core processor, this challenge is much more complicated. Using the capabilities of PikeOS, along with good knowledge of the target hardware platform, are crucial for overcoming this challenge. To perform the necessary testing, the LDRA tool suite is able to run many test cycles, generate interference across various interference channels, and provide visualizations as well as detailed tables of the timing analysis. In the diagram, the timing graph on the left shows the case where software is running on a multi-core processor without interference. The graph on the right shows the case where interference has been generated to stress the multi-core processor. Notice the distribution has changed shape with some clustering of execution times on the left and right sides of the curve, and with a more uniform distribution in the middle. Clearly, interference has had a negative effect on execution time. By leveraging state-of-the-art tools such as the LDRA tool suite, together with Cisco's PikeOS and the Codio IDE, developers can seamlessly integrate security and safety considerations into their development processes in parallel, thereby enhancing the resiliency and reliability of their systems while reducing development effort as well as certification time and costs. By leveraging static analysis to perform code reviews that assess compliance with both safe and secure coding practices, as well as assessing code quality, maintainability, and testability, and reporting on data and control coupling paths in the code, the number of development iterations and verification iterations to achieve compliance with functional safety and security standards is greatly reduced. Similarly, using dynamic analysis techniques to satisfy safety and security objectives in parallel reduces the time, effort, and risk of rework and repeated verification cycles for meeting compliance objectives. If a verification tool is used to automate verification activities, most safety and security standards require that tool comply with tool qualification requirements. For some standards and safety integrity levels, the tool qualification effort can be reduced if a tool is pre-certified for use. Third-party organizations like TÜV audit the tool vendor and their software development process to ensure that an appropriate software development process is being followed. For standards like DO178C, regardless of the tool vendor's claims, tool qualification is required. In these cases, Tool vendors offer tool qualification support packages to help customers establish compliance of tools for a given standard. The content of these packages greatly simplifies the tool qualification process. Some vendors also offer certification services for customers that want help with tool qualification. Having discussed many of the challenges of software certification, it's clear there is a lot of testing that needs to be performed. The results and reports of those tests are critical because they form the bulk of the evidence required to document compliance with functional safety and security standards. Managing all this information can be difficult. One way the LDRA tool suite addresses this challenge is by providing compliance reports customized for specific industries. For example, the DO-178C compliance report shown on the slide includes all the individual reports and test results that can be used to satisfy DO-178C objectives. Having all this information indexed and navigable makes it easy for both engineers and certification authorities to access and examine the artifacts and evidence. With the rapid growth of software content in many modern embedded systems, it's common for development and verification teams to include many people spread across several geographical locations. To support these distributed teams, it's important to be able to organize and aggregate all the software verification reports and results, and to be able to visualize testing progress and trends throughout the software development lifecycle. LDRA Vault works together with the LDRA tool suite to provide this organization and aggregation. Imported reports and results across multiple users and projects are collected into snapshots. Using the snapshots, LDRA Vault generates visualizations such as heat maps and trend graphs that users can explore to discover the root causes of issues. Earlier, Joe explained the importance of DevSecOps and how SYSGO supports it. In addition to making sure security is a priority at every stage of software development, DevSecOps provides consistency and governance over development and verification activities. The LDRA tool suite supports many DevSecOps and continuous integration platforms. The tool suite is fully command line enabled, and all the static analysis, unit testing, and dynamic analysis capabilities are fully available through the command line interface. By incorporating static and dynamic analysis into automated workflows, developers can identify and address safety and security issues early in the development lifecycle, reducing rework and improving the quality of software. Verification engineers can be assured the software they test will result in fewer issues requiring remediation and repeated verification activities. In addition, all the test reports and results generated from automated workflows can be imported into LDRA Vault to generate visualizations to monitor project trends as well as the overall progress of verification activities. We've covered a lot of ground in the webinar, so I'll conclude the presentation with a review of the challenges of certifying next-generation avionics software and the business benefits of using SYSGO and LDRA together to overcome the challenges. As we mentioned in the beginning of the webinar, the biggest challenges in certifying next-generation avionics software are addressing emerging markets and new use cases, managing the scale and complexity of certifying rapidly growing code bases, adopting agile approaches and improving automation, and addressing the growing number of cybersecurity concerns. Failure to overcome these challenges will leave companies unable to take advantage of these new business opportunities and may result in legal, financial, and regulatory problems. SYSGO and LDRA provide a comprehensive set of capabilities enabling companies to overcome these challenges. Both SYSGO and LDRA have extensive expertise and a strong track record in the aerospace industry. PikeOS, the Codio IDE, and the LDRA tool suite provide both flexibility and scalability to meet new and emerging use cases for both manned and unmanned aircraft, including eVTOLs. SYSGO and LDRA solutions are designed to meet the highest safety and security standards. As there is increased scrutiny of autonomous systems and a projected dramatic surge in the number of small aircraft, failing to deliver safe and secure avionics is not an option. Using SYSGO and LDRA together provides a strong safety and security framework that is efficient and cost-effective. Finally, both SYSGO and LDRA solutions provide extensive support for DevSecOps and continuous integration platforms, allowing companies to strike a balance between pushing innovation and making sure safety and security validation is thorough. Thank you again for joining our webinar today. If you have any further questions about overcoming the challenges of certifying next-generation avionics software, or how the solutions from SYSGO and LDRA can help provide both flexibility and scalability to meet new and emerging use cases for both manned and unmanned aircraft, please visit our websites and contact us using the QR codes and email addresses on this slide.